Hello, today we're going to be looking at Activity 3.2, which is Lab 3, Part 2, Testing Newton's Second Law. And you remember Newton's second law is acceleration is force divided by mass. Okay, so what we're using here are the same gliders that we used in the last lab, Part 1. And so anyway, now we have what are called amusing cargoes. And so the cargoes that we have are apples, eggplants, jelly beans, and a loaf of bread. Now you only need to record data for 3 of these. So let's look at the apples. All right, now in your instructions, one of the things is that you're going to need to measure a force. The force is being provided by the fan cart. So the turbine is producing a constant force. So what's going to happen is the turbine's going to blow air out to the left, and that will push the cart to the right. So let's watch that. Now you'll see that you get a top view here. Here's a scissors cutting the tape, and the cart moves. So one of the things you need to do is measure the force of the turbine. And the way that's done is that you measure it back here. And the top view there is of a spring and a piece of tape that are very hard to see on the side view. So there's an upper camera that's staring down at the tape and the spring. And so what's going to happen is that this, the tape I'm talking about is this gray piece of old film tape. Anyway, recording tape. Anyway, so that's what they're using, and they're going to cut that. But first of all, we have to go back and see how much this spring is stretched, because that'll give us the force of the fan. And so the force is proportional to the distance that the spring is stretched. So what they've given us is actually a force ruler. So the further the spring is stretched, then the larger the force is. Okay, so what we need to do is go back and find a point where the tape is relaxed. And so the fan hasn't started yet. And what you're going to do is place your 0 on either a little bead or maybe the blue tape. And so then you're going to be measuring the distance that the spring changes once the fan is turned on. So start your fan. Now the spring is extended, and you can see that from its old position, it is now extended 1.55, around 1.56. And that will be in newtons of force. So that's going to go in your data table down here. Okay, so now you've got your force. And remember, you only have to do 3 of these. So just pick 3 to do. And the next thing that you're going to do is measure the acceleration by finding how far it goes and how much time. So we don't need the Newton ruler anymore. You're going to need a regular ruler and your stopwatch. Okay, so you're going to go to a point where it has not yet started moving, and you could put your 0 at the edge of the cart, or I like maybe on this where the turbine is. That's a nice sharp edge. Anyway, so and what you're going to do is go to the point where the tape gets cut. So wait for the scissors to come in. There come the scissors. And you can see over here the scissors are approaching. And they cut. That's the point where you want to have your 0 time. Okay, so then you want the distance to be about 70 centimeters, so let the cart go for about 70 centimeters. Okay, 80 is fine also. So anyway, so make your cart go to a point where you feel comfortable measuring it. And so the edge of the turbine there, my time is 1.275 for 80 centimeters. Okay, so 1.275. And the distance, don't just put 80 in. Make sure that you remember that this has to be in meters, so it's going to be 0.80 centimeters. Okay, now you've got the data. That's all the data that you need to collect for each one. So do that for 3 objects. You're going to calculate the acceleration. To find the acceleration, you're going to use the formula distance is 1/2 at squared. Except we're going to solve for acceleration. So the formula is, turn it around, its acceleration is 2 times the distance divided by t squared. Okay, now, no numbers have appeared in here, but you can make the program do the calculations for you. So, the way that you do that is you can set a formula. So, the formula we want is 2 times the distance over t squared. So, the columns become your variables. So, I want 2 times the distance divided by, and I'm going to put it in parentheses, the time, and then use the caret here to raise it to the exponent, divided by the time squared. Okay, so 2 times the distance divided by the time squared. That's a formula, and now the calculation occurs automatically. And you can also write a formula for the next thing. You're supposed to determine the system mass. To find the mass, you're going to be using Newton's law. And the law is the mass is going to be the force divided by the acceleration. And that's going to be the mass of the whole system, everything, not just the cargo. And in fact, since the glider, the turbine glider is 800 grams, the reg glider is 200 grams, the total mass of the cargo, of the gliders, is 1,000 grams. So anything over 1,000 is going to be the mass of your object, which is what you're going to determine. Okay, but first you can put in this formula. Mass is going to be net force divided by the acceleration, and you can put in that formula, right? So net force divided by acceleration. Easy as can be. Okay, now that again is the whole system mass, and you can see that this is over 1. So this is 1 kilogram, 1.58 kilograms. So you can subtract off the 1 kilogram. That belongs to the gliders, and what's left is going to be your cargo. So you can even put that in as a formula. So just take your system mass and subtract 1. There you go. So anyway, so it's pretty easy once you put in the formulas. Of course, you don't have to. You can do them all with the calculator. But it's kind of fun to put in the formulas, and then you just need your 3 measurements times 3 objects. Okay, so have fun.